So, good morning, all viewers of this YouTube channel. We are here for the another episode, or the last episode of this webinar series. It's day 5, and we have today our guest with us, Professor Shabana Mehfuz of Jamia Millia Islamia. And I would now like to invite Dr. Imran to brief her on her bio. Imran sir,
Thank you,
please.
Gusar. It is a pleasure for me to introduce one of our eminent personality, Professor Shabana Mehfuz. Shabana ma'am has received his degree from BTech degree from Jamia Millia Islamia in '96 and and MTech degree from in computer technology from IIT Delhi and PhD from Jamia itself. And he's the also a merit holder, and he has more than 21 years experience. She has published more than 70 papers in journals, international journals and conference and journal of repute. She has guided 7 PhD and currently supervising another 6 candidates. She is a senior member of IEEE, life member of IST, member of Institution of Engineer, and the life member of Computer Society of India. She has received grants for research projects from agencies like AICT and UGC. She has acted as track chair for 2 flagship international IEEE conference held in 2015 and 19. She has been awarded International Women Award 2020 for Best Performer in Government Award by CSIR Foundation. Her research interests include computer network, cloud computing, network security, and computational intelligence. So there are more to tell about the ma'am, but I hand over the stage to the ma'am. Ma'am, please. And thanks a lot. You spare time for our webinar from your busy schedule. Now, stage is yours, ma'am. Thank you.
Thank you, Dr. Imran. Thank you for that nice introduction. I hope I'm audible clearly. Should I proceed with the talk?
Yes, ma'am. Yes, ma'am. Please continue.
Okay, thank you. Okay. So as this webinar, the main theme of the webinar is basically the fourth industrial revolution, and with special emphasis on the major technologies which are there in the fourth industrial revolution, Industrial 4.0, that is cloud computing, AI, and IoT. So I think already in the previous webinars, the audience have already received information regarding the fourth industrial revolution. So I'll just start quickly with it. So basically, this industrial revolution which started from 1700, where the birth of factory happened, and then from 18 to 1900, the assembly line and the mass production happened. From 19 to 2000, it was all about the personal computer and the internet. Now, beyond 2000, there was a rise in some very new technologies which have been there. Okay, so where in our webinar, the focus is basically these three, that is the cloud, IoT, and the machine learning. Robotics is also one of the technologies which has, taken birth here in this beyond 2000 industrial revolution 4.0. So that's the reason why we are talking about this topic today, that is cloud, okay, cloud computing, and specifically cloud security, the issues and challenges which are existing there. So the thing is that this entire topic is having a great, enormous, breadth as well as depth. But I'll just try to cover up some, basic concepts so that you get an idea of actually what exactly cloud computing is, and then what are the important issues and challenges with respect to the security aspect of it. Okay, so what is basically cloud computing? Okay, so this definition which is given here, that is the cloud computing is a model, okay, which is basically an on-demand network access. And in this case, we are basically sharing, which we are using a shared pool of computing resources which can be configured. Okay, so what are these resources? These resources are networks, servers, storage, application, and services, which can be provisioned very rapidly. Now, this definition has been given by NIST, that is National Institute of Standards and Technology, which is one of the premier institutes which is responsible for all the standards. So it's basically cloud. What is cloud computing? It is basically an on-demand delivery of the computing power, database. It could be storage, IT resources. So the most basic way to define what is cloud is basically, it's a computer which is being used, which is located somewhere else. Okay, so you're not spending on that computer, you're not buying that hardware, you're not buying those resources, you are basically paying. Okay, you're paying for what you use. So basically what the cloud is comprising of, it will be comprising of the server computers, which could be located anywhere in the world. They are large data centers, they're around the world. Okay, so there are many cloud service providers which are out there. Okay, so we call them CSP, that is the cloud service provider. So they are the ones who are going to provide us with this on-demand network access to these shared pool of resources. So this is basically a generic definition of what cloud computing is. So we move on to the this thing, that why do we call it a cloud? Actually, why the term cloud is being used? Okay, so the term cloud is used, why? Because because the cloud is something which is somewhere, okay, which has certain resources. So similarly, we have some resources which are located at a place, okay, which are owned by some third party, okay, somewhere else, and the customer or we are basically using it. So that's the word. And there's no clear picture of basically who coined this term cloud, because there are a number of people who had started talking about it majorly towards like 1997 or so. Okay, so that term was being used by a lot of people, and finally it had some definition was given to what is cloud and what is cloud computing. So some examples by which you can understand, actually, some examples that we have been using all the time, but we may not be aware that this is basically cloud. So like, for example, the Google Docs that we use every day to upload spreadsheets, and the Google Docs, the email that we're using, the Gmail, Hotmail, Yahoo, all these email providers, that is what we are doing. It's an example of a cloud computing implementation. YouTube, we are looking at YouTube videos all the time, so that's another paradigm of cloud. All these social networking sites, Facebook, Twitter, and all. So all these are examples of cloud computing services that we are availing of. Okay, so and there are some specific services like high performance cloud computing, which researchers might use, big research companies, or for example, because high performance computing clouds means we need resources which have high performance in computing. For example, high performance computation could be weather forecasting, where we need supercomputers to which are using AI for predicting the weather. Okay, predict storms, etc. Okay, creating new materials. Stock market could be using it. Okay, for financial markets could be using it. So that is the high performance computing clouds. So as you can see, it has a wide range of application. Cloud computing in our life has wide range of application. You name any business, yes, fine, you will come to know that this business can use cloud computing and get hold of all the advantages that cloud computing is offers, and business can expand and flourish. Okay, so it's like that. So these are some examples which are there showing the advantages of why one should go to use a business should go to cloud and use its services. So these are some examples, because when you're moving from something to something else, we always compare. Okay, so that's very important. Comparison will always be there, and when we want to use something, obviously we look at the advantages. Okay, so this is kind of like giving the advantages only, and everything has a disadvantage also. But yes, fine. But the advantage, there's a trade-off. So we do the trade-off whether the advantages are heavier over the disadvantages. So we go for that. Okay, so this is traditional computing versus the cloud computing. Okay, so yes, it is self-provision. Okay, it happens on a lot of automation is there, fine. So that's why we call it self-provision, whereas the traditional computing that we were, doing all this time was manually provision. Definitely, it's a shared hardware. There will be other tenants which are going to be there. Okay, for example, you are having a Gmail account. There is another person having a Gmail account. Okay, so there are a lot of people who are going to have the Gmail account at the Gmail server. So it's a shared stuff that we are using. Traditional is fixed, okay, unless and until you increase the hardware in your on-premises, you have systems, you have hardware, it's all fixed. You want to change, yes, you can, but definitely you'll have to add hardware, then you add hardware, and then you need to have space also for doing that. Okay, whereas if you are moving on to cloud, it's having elastic capacity. You can anytime, initiate instances of machines, virtual machines. You can, so you just need to pay actually for whatever you use, you pay. Okay, so here in this case, therefore in traditional computing, what you're doing, you're paying for the capacity. Okay, but here what you're doing, you're paying for the use, because you don't own that hardware, that infrastructure, or that platform, or that software. You are just using it, so you just pay for it. Whatever amount of time you're using it, accordingly you are going to pay for it. Okay, so in case of traditional, you will have to go for all the the capital cost. Okay, that is there. Expenses will be there, as well as the operational expenses also you will have to spend upon. Okay, whereas what happens in a cloud, because this is going to be managed and owned by someone else, the infrastructure, the platform, so you are just going to pay for the operational expenses. Okay, so and then if you are having an on-premises computing stuff, it means you have to have system administrators who are going to manage everything. Okay, the IT system admins were going to look after the system and everything and manage the system. Whereas in this case, for clouds, we have APIs, that is application programming interfaces, which are basically some software intermediary that allows two applications to talk to each other. For example, like in your phone, like mobile phones, you are using that Facebook, this thing. What is it? It's basically a Facebook app, or a messenger. It's a messenger app. Okay, so they're all apps, and you're checking, let's say, weather on your phone, so you're using an app. So all the time, these are the APIs, which is like a front door of the whole system, and you're through the front door, you are using those services. So this is the concept which comes into picture when we are moving from the traditional computing to the cloud computing. So this is a comparison which is there. Okay, so before moving on to the security part, we basically should know some major cloud characteristics, because the problem is that characteristics which make it so advantageous, at the same time those characteristics are the one which are the cause of certain concerns which are there, which can be handled definitely, but it is still that all standards are there. Some standards are there, some standards are in the nascent stage, they are developing. Okay, so that could be a research area to work upon, where you can work on those. So these are some of the essential characteristics. You have the on-demand self-service. So customer can provision the resources automatically. Okay, it's automatic when required, without the need of some interaction, okay, with a service provider. So the interface is quite easy. Then obviously the second the essential key attribute is the broad network access. So capabilities are available over the network and will be accessed through the standard mechanism, okay, such as, let's say, mobile phones, laptops. Okay, so you need to have internet. Then resource pooling. Okay, so the provider who is providing with all the resources, basically its resources are pooled, to have multiple consumers using it. So it's a multi-tenant model. So there are a lot of tenants. You're hiring something resource from the CSP, the cloud service provider. So you become a tenant. So like there are a lot of tenants which would be there. So it's a multi-tenant model which is being used actually. Rapid elasticity. Okay, so as I just mentioned earlier, also it's the elastic. It's not fixed. Fine. So capabilities, can be elastically provisioned. Okay, some case you want to increase the so basically the elasticity refers to the ability of the cloud to automatically expand. Okay, the infrastructure resources or other resources which you want to have it, which you want to have it. Fine. Let's say you have some amount of resource you've hired, but you want to increase it. So elasticity is there. You can do that. Okay. It's all about you make the payment according to what you have used. Measured service. So resources, these all the resource usage which is happening from your side, okay, that usage is going to be monitored, it is going to be controlled, and it is also going to be reported. Okay, so fine. So these are the some of the very, very important characteristics. And how do these characteristics they benefit the business? Just one small example I would give here. For example, there's a stockbroker. Okay, so for his or her business, let's say he has he has around, like, say, 100 users. Okay, so he would basically, the market opens at around, I say, let's say 10 o'clock or something, maybe something like that. Okay, and by 3 p.m. or so, the work is over for him actually. So what is the point, having the whole setup, having the whole resources available, and establishing it, and then keeping it, it will be just a waste of resources. After 3 p.m. the resources that he is going to generate, he's going to set up, okay, on premises, is going to be a waste actually. So so that person can save a lot of money, okay, by going on to cloud computing, because he or she just requires the system and the whole entire system just for this duration, that is, let's say, 9 to 3 p.m. So in such a scenario, this is going to be a win-win situation for that particular person or that particular business. So these are the essential characteristics that we need to understand, which play a very important role, whereas the cloud computing is concerned. Okay, so okay, just a minute. Yeah. So okay, so these 5 characteristics, what is there with the various standpoints? So for the developer standpoint, a lot of flexibility is there, because the developer can create content, deliver it, okay, the applications everywhere. What is the advantage with the IT standpoints? The cloud computing basically allows organizations to free themselves from having to procure everything, allocate hardware, have system admins looking after everything, the network resources, the hardware, the software, and applications, and everything. Okay, so that becomes easier. And obviously, from the business standpoint, the cloud computing is enabling providers to serve business of all sizes, especially these small and medium businesses. They're going to really benefit from this stuff, because they don't have so much of capital to spend on everything, so they can right away start their business using and flourish, and have profit if they use, because they will just paying for the amount of capacity. Suppose on day 1 you require this much of capacity of systems, you just do this. Let's say for a week you need this, for the next week you will be needing more, so you can increase. Then if you suppose the load has come down, you can just again decrease it. Okay, so which is not possible in a fixed kind of resources that you have generated at your end, actually, in your office, okay, in your building. Okay, because they will always remain there. You can just add and subtract. You will have to spend on the maintenance and everything, okay, all the time. So that is not going to be so much of benefit. So these are the benefits which are there to the business in case you are going to cloud for the small and the medium ones. Okay, now, okay, so next comes the models. So there are 3 basic models which are there. There are other models also which have come up, but these are the basic building up block models, like stuff which is there. So we have AS, we have PaaS, and the SaaS. Okay, so how are they different? Basically, the first one, some examples are given here. So with the AS, what is happening, that is, you manage the server, which can be physical or which can be virtual, and also the operating system. Okay, so both are yours headache. Okay, if you take that, if you employ that kind of model. So these are some of the examples, like Google Compute Engine, and there are some deployments of Azure and Amazon Web Services. PaaS is the one where you are using the platform as a service. Okay, so you are also getting the OS from there. So it enables ones to run applications, without managing the infrastructure. Okay, so though that is not your headache, so your headache is bit less actually. So some examples are databases such as MySQL or Oracle, or like web servers. Okay, and the last one, that is SaaS, is the software as a service. So this is where you are least bothered about the lower levels. Okay, the lower levels, the responsibility is less. So that means that this is basically, you can say that these categories are based upon how much control and responsibility is there for the provider and is there for the customer. Okay, so this is basically based on that parameter, that how much of control and responsibility is towards the two parties. Okay, so there is a difference between that among these three models which are there. So with the SaaS, that is software as a service, you have to just manage your files. Okay, the service provider will take care of the data center, the server, the network, storage, platform, everything. Okay, so all these examples that we are using, the Gmail, Facebook, Netflix, these are all examples of SaaS software that is there. So these are some of the models which are there. Then comes the deployment model. Okay, so we have different deployment models. Okay, so which is different business can take up different deployment models. So a private cloud is the one where obviously maximum expenditure would be there. So a private cloud will be operated and maintained, okay, by a single organization, definitely. So that's why the word private is there. Public would be the one which is going to be run and managed by the cloud service provider. Okay, so these are Amazon Web Services, Microsoft Azure, and Google platform, cloud platform that we all use. You know, the Google Drive and all. It's basically a public. They're all public cloud providers. They are providing the public cloud. Okay, community cloud is a cloud which you can say is a public cloud, but only restricted to certain groups. You know, which have some special interest. For example, I have an example like there's a US-based dedicated IBM software cloud only for the federal agencies. Okay, so that's a community cloud which can be accessed only by them. Okay, so it is basically a public cloud, but in the domain of one special interest group, which will have access to it because they have all common interests, so they are going to access it. And then comes the last one. There is a hybrid. Okay. So business can have both, you know. So hybrid will be mixing up of the two cloud infrastructure. You have you're using the private as well as public. Okay, so both are there. So one can get advantages of both the type of deployment models, and as advantages as well as the disadvantages will also be there. So these are some of the deployment models that that is there for the cloud. So then we can look at this. Okay, fine. So whatever we have discussed till now, this is just put together, showing the architectural framework. Okay, as you can see, we have all the deployment models. Okay, so you have all the deployment models. You have all the software models. Okay, so you have SaaS, you have PaaS, and infrastructure, and anything could be provided as a service. So we have the management has to be there, security, privacy of the services. We have the cloud service models that we have already seen. Cloud service provider is there. Okay. Now there is a entity known as the carrier. So the carrier is basically the connection or the communication link. Okay, which is going to be the medium. Then consumer is there on the other side. Okay. And then we have one entity which is being shown here as the cloud broker. Okay. So cloud broker is generally an application or an individual which basically acts like an interface, okay, between the client and the provider. Okay, they have some functionalities of keeping all the checks, okay, and maintaining the logs, okay, provisioning. It helps in provisioning also. So this is also one more actor. There are certain actors. So there's the cloud consumer is one actor. Okay, so the provider is one actor. So the broker is also another actor which is present here in this framework. So this is the framework that we have. Okay, so as we have just seen, these are the, okay, fine. So, okay. Fine. So before moving on further, this is one important concept which basically helps in the provisioning of cloud computing. That is basically cloud computing leverages this property, that is virtualization. Okay, so what is virtualization? This is what is shown here. Okay, so there are, as you can see in this structure, what we have is we have the physical host, the host operating system. So this is the one which is given to for the cloud service provider. Okay, there is one entity given a hypervisor. Okay, and as you can see, there is a kind of co-residency happening here where different clients are having their own virtual machines. Okay, so this is what happens. It's a shared pool of resources. So all the resources of this host system is being shared by the host, or the by the shared by the guest. Okay, and upon that you have the above that you have the user tools and services. Okay, so this hypervisor is something which is unique here in the cloud computing, and this also is a cause of concerns when security comes into picture, because see, cloud itself has is going to be affected by all the cyber security attacks which are already there, okay, in picture. Like internet is obviously prone to certain attacks. So because cloud is using that, so definitely it will be also be prone to those attacks which are already existing for the cyber systems. Okay, fine. But then introduction of this hypervisor. Now, what is this hypervisor? This is basically a virtual machine monitor, or we also call it a VMM program. Okay, so this is a program that is used to manage the processor scheduling and the physical memory allocation. Because see, what is happening? These all these tenants or these guests are going to reside here. Okay, have in terms of the virtual machines. Okay, so all this isolation, there has to be an isolation among these virtual machines because they are different, guests which are there, different tenants which are there. So all that has to be managed. So who manages this? The hypervisor. Okay, so this hypervisor is a new entity which is present here in this virtualization concept for the provisioning of the cloud computing. So a VM will be created for the client, okay, in the actual physical resources. So each of the client, that is the customer, a virtual machine will be created. So what will happen? An account will be created for the client, and then access will be provided the moment the payment has been done. Okay, so this is how the cloud computing is going to work. So if you want to look at the definitions of virtualization, okay, these are some definitions of virtualizations which are there. Okay, so virtual means something which is not present, but we think that it's there. Okay, so virtual, okay, which is imaginary, but it is, the physical thing is there, but virtual seems to be different. Okay, for us it is going to be present there. So it's an act of creating a virtual version of something. So as you can see in the previous diagram, the actual thing or the physical thing is the resources of the host. Okay, but when the tenants, they hire those resources and a lot of tenants are present, for each of the tenant, it's like, it's all my machine, but it's not that. It's all my resources, but it's not that. Okay, it isn't like that. Definitely there are other tenants also, okay, using those resources. It's that they are segregated by some technology. Okay, so that is what is called, that's why it is virtual. Okay, virtualization. You think that, okay, fine, like I'm using my laptop right now, it's all mine actually, fine. But if I'm using a cloud resource, okay, I'm using some virtual disk or something, it is basically virtual because there are other people also using that disk. Okay, but there is a segregation. So for me it appears to be like, it's all mine, but it is not. So that is what is a virtual world or virtualization. Okay, so this is what we mean by virtualization. Okay, but with respect to cloud, is basically realizing that one or more complete computer system is, as guest on the base machine. So it has the ability to run multiple operating systems, fine, because each of the guests might be having its own this thing. Okay, the operating system might be there, right? So sorry. So cloud computing basically is using this virtualization technology for having a multi-tenant model. Okay. Fine. Okay, so what is happening? Basically, it's like becoming a tenant, okay, and rent it as and when needed. So there are like public clouds. For example, we have Amazon EC2, and there are lots others are there. Google is there, Microsoft, IBM. Okay, a company can have a private one also. It can have a public one. It can have a hybrid one. Okay, so when definitely in a private one, there'll be more control over the security because it is on because you have more control. You have everything to your own this thing. Okay, but when you are using a public cloud, definitely you can think that the security will be less because it will be not only your responsibility. It will be the responsibility of the provider also, and because it's a public cloud, everybody is accessing it. So then it becomes security, ensuring security becomes much more difficult. Okay, so this we've already discussed, like how cloud computing works. So one has to create an account. One is to create an account, okay, and fine. So one is to create an account. That instance is created. You choose the resources that you want. Okay, you can instantiate. You can pay, and you will be billed for what you use. And we are basically what all is which technology? Virtualization is the technology which is used for the cloud computing to work. So that we have already discussed. Okay, so now we come to so we are now very clear with like what cloud computing is, what are the different deployment models. Okay, so how does it work? What is virtualization? Okay, how it helps in having a multi-tenant model. Okay, so that part is clear. Now we come to the security, because that is very, very important when one is thinking like, let's move to the cloud actually, because you are handing over everything to somebody else. Okay, so that's why this is the major concern, exactly how safe the cloud is. Okay, so there are some facts. So this concern is not I should say that the concern is not just like that. Lot of surveys have been carried out. Okay, and this is the survey which has been carried out by IDC, the picture that is being shown here. This is the International Data Corporation, which is a premier global intelligence firm. And as you can see, what does it say? That security. So they have done a survey, and out of all these parameters which are listed here, security, performance, availability, how to integrate, customize, like all the stuff, 74.6% is the concern of security. So which means definitely people are really do have the fear still as to that how secure or how safe the cloud is. Okay, so as I said earlier also, the key attributes, the 5 key attributes that we have seen earlier, those attributes are the one that give it those advantages that we want, that makes it so great cloud computing. But at the same time, those attributes are the one which are making it less secure, and it's also added security challenges. Okay, now making it less secure, we'll discuss that. Okay, how adding security challenges, we have added the hypervisor there. Just imagine if there are attacks on the hypervisor itself. Okay, fine. So there are a lot of security challenges due to that hardware sharing. Okay, because once some certain things are shared, you are not the one who is using it. There are other people also using it. So they might look into your data. They might cause an attack on your machine, your virtual machine. So a lot of problems have come into picture the moment the hypervisor has come into picture. Okay, so the problem is because it's a new concept. Okay, why it is that? Because the traditional security controls which are there are not going to work, because it's altogether a new stuff. Okay, which is using things from the cyber systems, definitely properties and everything, but there are, because of this virtualization and sharing of those pooled resources, so many new concerns will arise which the previous traditional security controls will not be able to handle. Okay, so how does the cloud environment change? Okay, when you move over, if you're talking about security. Okay, so as you can see, you have your own data center and you're moving to cloud. So you have the control. Okay, it's located at some locations. You know that it is located at this particular servers. You also have backups. You have your system admin, having the control access. Fine. So, and auditors, they know what they have to audit. It's present there. Fine. And you employ a security team also to look after everything. But the problem with the cloud, you don't know who has the control actually. Okay, yes, CSP is there, but if it's a shared stuff, what all has happening, you don't know. It could be located anywhere. You know that cloud, the CSP has its data centers located all over the world. Okay, so backing up is there or not, no idea. Okay, access, okay, fine. So many people have access, public cloud. How resilient it is to attacks? Does it have a incident response plan? Okay, when an attack is happening, a proper incident response plan. Okay, auditors, how do auditors observe? Because auditors can only observe when the virtual machine is running. When it's not running, how do they observe? Okay, And how do your security team get hold of all that stuff? Fine. And do they have a security team which is taking care of everything, okay, which is monitoring continuously? Okay, so many concerns are there. So that's the reason when security comes into picture, the cloud environment has in a number of challenges which are there actually. Okay, so this again going back to the hypervisor, that structure. Okay, so you can see that the security challenges, then what are the new complexities. Okay, so in this it was a 1-to-1 ratio, okay, of the OS and the application per server, whereas here it is a 1-to-many ratio of the OS and the application server. Okay, and there is an additional layer which needs to be managed, the hypervisor, which needs to be managed and secured. Okay, so new complexities, challenges have arrived after we have going to virtualization, so that one can use cloud. So the co-residency, that is what is the term which is used. Okay, so as you can see, so okay, fine. So how security gets integrated? This picture shows clearly what is your responsibility, that is the customer's responsibility, and what is the cloud provider's responsibility as far as various deployment, various models are concerned. Okay, so as versus PaaS versus SaaS, and obviously on premises everything is the customer's responsibility. So you can say in as the lower layers which are there, the hypervisor, infrastructure, physical, that is the cloud provider's responsibility. Whereas in PaaS, obviously two more added on to it, the operating system and the network traffic. Whereas SaaS, so you can say that the vulnerability order is basically decreasing as you move from the as to the SaaS. Okay, so for the as, user is responsible for handling more security control if you compare it with other models which are there. Okay, so just on the lighter note, so definitely if people's biggest fear is not data security, so let's imagine what will happen if there is a thunderstorm. Okay, so what will happen to the cloud? Okay, so it's a matter of concern, but it's not that concern cannot be taken care of, definitely. Okay, so these are some reasons that we have just seen that picture. Okay, as versus PaaS versus SaaS. Okay, so what are the reasons? Someone else is looking after data, obviously, so that is a problem. So it's not completely in your premises. Cyber attacks could be there because you're using internet. Okay, so all the cyber attacks which are possible on any system connected to the internet will be there. Okay, so they are already there, that we have to take care of. Insider threats, insider security breach are very you must be aware of that is already happening in the on-premises system also, and this could cause a great loss if as far as cloud computing is also concerned. Then government intrusion could be there. Government could be looking after your data, whatever you are storing, everything, because it is in the cloud, so it is not on completely on your premises. Legal liabilities are there. Some countries have their own rules, so sometimes if suppose you're using a cloud service which is outside the country, okay, then in that case whatever are the rules which are going to be followed by that countries, the country must be having some policies, thus that guidelines have to be definitely followed. For example, the European Union has come up with the GDPR, so okay, and there is a data protection bill also which is going to come up recently. So if it is that particular server, that particular service is that the cloud service is in that country, those rules and regulations and policies which are formed from time to time have to be followed. Okay, standardization, definitely there is a lack of standardization, as standards are in nascent stage, they are being developed. Okay, so unless and until they're fully developed, the problems will be there. Okay, and as and when the problems will be encountered, this will be taken care of. Lack of support, sometimes the cloud providers, they do not provide the required customer support which should be done, so that is also a worry which causes security concerns also. Now this is something which is very recent actually. There's an organization known as Cloud Security Alliance. It's the world's leading organization which is dedicated to defining the problems, the issues, and raising awareness about the best practices that one should ensure to have a secured cloud computing environment. So according to the latest survey, so they have been doing service, okay, off and on. The previous survey, they had more issues actually, and some of the issues with time have just gone away. Okay, they have vanished. So with the ranks, you can see the issues are mentioned here. We call it the cloud. They called it the Cloud Security Alliance egregious 11. Okay, so out of those 11s, the ranks which are shown, okay, so 1, 2, 3, 4, 5, all to 11 are there, and the ranks which is shown here is the previous rank. Okay, so as you can see, the first is there. It's there. It was there on the first. It was the first rank holder previously also. Right now also it's having the rank 1. Okay, so the previous ranks are also mentioned here. So these are some of the major issues which are there currently, which this is according to a very, very recent survey. Okay, so what are the takeaways from this recent survey is, as compared to the previous survey, because they had a previous survey also. So these are some important takeaways, because these takeaways are important because if one looks at compare the previous and the recent one can see over the time what are the attacks or what are the issues which have vanished, and then what is the reason. Okay, the one has to know the reason also. Okay, so that can be employed further. Okay, so what has happened is there's a drop in the ranking of traditional cloud security issues, okay, under the responsibility of the CSP. So what does it mean? That the issues or the security responsibility which was under this thing, that's a CSP, they have vanished. That means CSP has kind of improved their systems, improved the security features, improved the security control. So what was their part, that they have improved upon it. Okay, so that means that denial of service, shared technology vulnerabilities, and CSP data loss, and these were some of the security issues which were there. They have vanished. They are no longer in the list. Okay, that have just shown. Okay, according to the recent survey. And there is a need to address the security tax situation higher the technology stack. So this is what has come out of the recent survey which has happened. Okay, so this picture basically what it shows the issues, their rank. Okay, and who has the responsibility for having this solving this issue. Okay, for even stopping these attacks, and what are the cloud service models which are prone to these attacks. Okay, so this picture basically summarizes the entire thing in just one picture. It has been summarized all these 11 problems which are there. We'll just quickly go through these 11 issues. We are like short on time. Okay, so data breaches, basically it's breaching of data. Okay, that means data breach is basically the primary objective of the target attack is to acquire the data and then misuse it. Okay, so I can just give an example. For example, Uber disclosed that its Amazon Web Service was hacked in, I think, late 2016 or something, and it really compromised the information of so many account holders there. So it's a big problem. So whenever some kind of attack happens, all the data of the account holders is breached. Okay, so what are the key takeaways from this? That encryption techniques, okay, need to be improved, or the encryption techniques have to be incorporated. Okay, and to make the system much more robust, and incident response plan should be there with the CSP. Okay, see, the thing is that this whole securities thing is basically a shared responsibility. It's not that you just put the responsibility on the CSP. You need to take care of your part. Okay, the customer needs to take care of that part. It's a shared responsibility model, kind of shared responsibility model. Okay, so one has to not you can't okay, obviously the customer cannot do all the monitoring on his own. Okay, but whatever is required as far as the service SLA is required, the agreement is concerned, all that has to be taken care by the customer, that whether all the clauses are present in this SLA or not. Okay, so all this has to, whatever is the part of the customer has to be done by the customer. Okay, misconfiguration, lot of misconfiguration which is there while the provisioning will lead to a lot of problems. Okay, like you give excessive permission to somebody, okay, which is not required. Okay, the security controls which has to be enabled are disabled. So this can lead to a lot of attacks. So this is all related to the misconfiguration issues which are there. Okay, so what should the companies do? They should basically embrace the automation, okay, and employ technologies, so that the scanning of the configuration should be done periodically, continuously, periodically, whether the controls are disabled or enabled or not. Okay, what is the configuration which is there, whether it has been done or not. So all this has to be monitored by the customers. Okay, so that monitoring, continuous monitoring of this will be required. So that automation should be there. Some software could be employed which could continuously monitor everything, even continuously monitor the traffic, and report some abnormalities which are there if you compare to the threshold values. So in fact, softwares can employ AI, can employ deep learning, machine learning for this monitoring operation, and recognition with the help of the pattern. Okay, lack of this, the third one which is there, lack of security architecture. Okay, so this basically leads, so in this case what is required is that perfect security architecture framework has to be implemented. Threat models needs to be created. It's very important. Okay, a lot of this is something new which has come up. Threat modeling, that is, a model needs to be created where what all the threats could be there, what should be the incident response plan, how will it act. Okay, and continuous monitoring, as I said, continuous monitoring is required. One example is like in 2017, actually, the cloud giant which Accenture, okay, they recently confirmed that they have lost a lot of private data because they left some unsecured Amazon S3 bucket. So they lost a lot of highly sensitive password and secret decryption keys. Okay, so the data could be available to the attackers, okay, and could be misused. So a lot of such incidents have been happening. It's not that it's not happening. A lot of such incidents have been reported. Now, this is very important. That is insufficient identity management and key management. Okay, so what all can be done to ensure this? Two-factor authentication. Like you must have used, like for example, when you're paying, as you can, let's say you're buying something on the Amazon website. So you will see that when you enter your password, your PIN and everything, after that, you get some security questions, or let's say you get an OTP. Okay, so these are basically a two-factor authentication system, or we call it multi-factor authentication system. So this is very important because then it is authenticated twice or a couple of times. Like for example, when I log into my Gmail account from, let's say, some other system, I'm using a laptop and I just log in from some other system. Okay, I'll get an email on my registered email ID. Fine, that you have logged in from so and so and so. So this is all very important. Okay, so this is what is multi-factor authentication scheme, which is there. Keys, management of keys is very important. So there could be a software at the customer side also, which can just keep monitoring and checking if the key have been rotated or not. Okay, some kind of unused credentials are being used. Okay, so for example, you're running a company, you have provided access to certain employees. Okay, now that employee is leaving the company, so that access needs to be revoked actually. Okay, otherwise it could be misused. So one I can cite here that attackers, they recently scrapped GitHub for the cloud service credentials because some were there hidden in some projects. So it could be misused like that. Account hijacking, so that is definitely some malicious this thing can hijack the account and misuse the data. For example, that happened in Tesla, I think in 2018. Elon Musk had reported that some employee who was not given promotion or something, they used his or her credentials for exporting large amount of highly sensitive data to some other third party. That happened in 2008. So this account hijacking is also a very, very serious issue. It could happen. And it could be an insider attack because all the types of attack, external as well as internal, could be happening accidentally also, and could be happening deliberately. Both the categories are there. Okay, so this is the insider attack. Okay, so some individual who is like rogue, or it could be happening to, as I said, it could be it accidentally also, it could happen deliberately also. Okay, so what should be done is, we need to educate everybody about the security issues. Okay, so a lot of training and education needs to happen, awareness. Okay, routine audit should be happening. Okay, scanning should be happening for the system, and then there has to be hierarchy to the critical systems. Only very restricted access needs to be provided. Okay, so we need to group people into different categories. So it needs to be the access should not be provided to everyone. Okay, so there should be a hierarchy in the access control that has been provided. So this is all the key takeaways for the insider threat. Now, as we have already discussed about APIs, as we know that APIs are like kind of the front doors, so you just keep open your front doors, you are inviting a lot of security attacks on the system. So one has to ensure the proper protection of the API keys. Okay, and one should use standard frameworks for these APIs. So the broken, exposed, or hacked API that can lead to the major data breaches with it. Facebook reported about this, like let's say in 2017 when they had a breach. So 50 million accounts, I think, were exposed to that API breach. So these are some examples of very, very recent security attacks which has happened. And this survey has basically taken care of all that and produced these 11 issues which are there. Okay, so control pen. So this basically this control infrastructure, if it is weak, definitely it will invite a lot of trouble. So the cloud customer should determine if the cloud service possesses. Okay, so that again, the customers, this is the responsibility of the CSP also, and the customer also. The CSP has to oblige with all the legal and the other obligations which are there, whereas the customer needs to check whether the adequate control plan is there or not. So it is a responsibility. Most of the time you will see most of them are the response. It's a shared responsibility, as I earlier also told you, that it's a shared responsibility. Now the metastructure and the appli structure. Basically, metastructure is the protocols, all the protocols and the mechanisms, that provide the interface between the infrastructure layer and the other layer. Okay, so we can think of like the infrastructure layer, cloud as an infrastructure layer. Above that, we have the metastructure layer. Above that, we have appli structure layer, and above that, we have all the applications and data and everything. So above the metastructure, we have an appli structure, which is an interface between these two layers. So each of the layer is an interface among the layers among which it is sandwiched. So again, all the structures have to work in a proper fashion. They have to be designed properly. Okay, so the cloud tenants or the customers, they should implement the features which are required. Okay, so, and lot of penetration testing. Penetration testing is basically a test which you do under a simulated cyber attack. Okay, a simulated cyber attack can happen. You can employ that and see whether your system withstands that or not. Okay, so that kind of testing is required for handling this issue. Okay, then the 10th one is basically the limited cloud usage visibility. So this could happen because of two things: either unsanctioned app use, or already a sanctioned app which is there that is being misused. Okay, so in this, these problems could occur, and there's something known as shadow IT. So basically what happens in unsanctioned app use, the employees are using the cloud application and resources without any permission, and so they don't have the permission, then also they are being able to use it. And sometimes they have the permission and they are being leveraged from inside. So this can be, so lot of issues you will see, they are kind of connected. One happened because of the other. Okay, if one happens, it can cause the other also to happen. Okay, so they are quite linked. All of them are quite linked. Okay, so these are all the takeaways. So out of this, obviously, it's a top-down approach. Okay, something very important here, which is mentioned, that you can use a third software, which is known as a CASB, Cloud Access Security Broker, which can do a continuous monitoring. It can flag alarms, if there is an unusual behavior, okay, because it has the threshold behavior could be there. And along with that, AI or machine learning could be used to identify the patterns of unusual behavior. So a lot of research issues are there, and a lot of work is there which can be done in this regard. And implementing a zero trust model. Zero trust model is basically when we are not basically, it's a security framework which requires all users, whether the from the outside or from the inside, they should be authenticated, they should be authorized, and they should be continuously validated for the security configuration. Okay, so it's a security is basically a continuous thing which is to be done. It's not that once you have implemented everything, the security architecture, the controls and everything, you got to monitor it. Okay, you got to monitor it, check it all the time whether it's still there. Some needs, there are some, whenever there is a changes are in the organization, whether you have changed that or not. So implementing a zero trust model across the organization will help a lot. And the last one is the abuse and the nefarious use of the cloud services. Okay, so we can have malicious attackers that can host, malware on the cloud service. Okay, that can cause denial of service attacks. Okay, email phishing campaigns, mining. So basically, enterprises have to monitor the employees. Again, monitoring comes into picture. Okay, and employ the DLP technologies so that it can monitor and stop any unauthorized use or unauthorized deploying of some software which is a malicious software, because that malicious software will lead to a total complete breakdown actually. Okay, so it's not there that okay, as far as the cloud service providers are concerned, yes, definitely there are some organizations and there are some standards, which they're supposed to follow. It's still in developing stage, but definitely these standards are being developed and these organizations are looking after. So CSP have to follow. Okay, so but the job of the customer would be to ensure that the CSP is, laid down everything in the service layer agreement. It's there, they are following that. So once one needs to move to cloud computing, that has to be looked after by the customer, definitely, that the CSP is following all the standards. You should go to the standards, see what are the clauses in the standards. So these are some of these companies like SOC, Service Organization Control, we have ISO, we NIST, CSA, we have PCI, that is Data Security Standards Council. Okay, so all these are the standards which are there. These are the sponsoring organization. Okay, so this table basically provides what are the organization and what are the standards they have laid down for the cloud service providers. Okay, so one can go through this before moving on to cloud computing to see what all these standards are basically talking about. So we reach the final conclusion that basically security in cloud is just not an option actually. Okay, it's not an option, it has to be done. Okay, if you're moving on to cloud and you want all the advantages and you want that advantages to remain there and not encounter problems, then it is a continuous process. Okay, so the best way to do it, stick to the best practices. The best practices for cloud usage, which has been given by CSA, the Cloud Security Alliance, and the NIST. Okay, so there is a lot of importance as far as the SLAs are concerned, that is the service layer agreement between the customer and the provider. Okay, so because that document clearly identifies what are the responsibilities of the customer and what are the responsibilities of the provider. Okay, so that you take up all the responsibility and ensure also that provider is following all the responsibilities which have been laid down in the SLA. So that will basically ensure that the principles of security are being taken care of. That is, okay, the CIA principles of the security aspect have been taken care of. So with this, I conclude my presentation. Mr. Piyush, are you there? Dr. Piyush?
Yes, ma'am.
Yeah.
Ma'am, let's take up some questions from the participants.
Okay.
let's take up some questions from the participants.
Yes.
I have posted mine first.
Okay. Should I stop sharing my screen? Okay, what kind of attack is more malicious for a cloud? Yes, the one on the top, egregious 11, that is data breach. Because see, why are people moving to cloud? What is the advantage? It's about data, about networking, and about access. So the moment your data, your confidential data, imagine let's say Amazon Web Service, you're obviously buying something. Sometimes you basically store your credit card information there. So just imagine if a data breach is there and millions of accounts are available to some malicious rogue person. What will happen? They're going to sell it off. So a lot of such incidents have happened in the past actually. So this is the that is the data breach. And data breach could happen due to a lot of other issues which are there. So as I said, all the issues are quite connected. One leads to another. So out of those egregious 11, it may be that 10 of them could lead to data breach. Okay.
Okay, thank you, ma'am. I have another question on your screen.
Okay. For SaaS. Okay, so SaaS
Which security
basically,
should
yeah, which
check?
could a cloud developer keep in mind for the SaaS? So in this, basically, it will be basically the responsibility of the customer would be regarding the credentials actually. Okay, you should not share your passwords. Okay, you should not leave your passwords unprotected. You should use a strong password. Okay, because you are basically logging in. You're going to use that service with the help of your login. So login needs not to be shared. The passwords needs to be authenticated. Okay, so you need to use a strong password. Follow the policies for having a strong password. Don't share a password. So this all regarding the password mechanism is very very important as far as this kind of service is concerned. Because in case of SaaS, as you have seen the comparison, if you're talking about the security controls, the customer has least amount of responsibility as far as the SaaS is concerned. More responsibility lies on the provider. Okay, which basically increases with as you go from SaaS to PaaS and ASTIP. Okay, am I
Okay,
audible?
ma'am. Ma'am, thank you so much. I have some suggestion from Shanawaz Ahmed. He's suggesting that cloud malware injection is most malicious attack. So I don't know about
Okay,
much about this field, but obviously I'll get to know about this.
okay,
I
yeah,
think it's,
fine.
ma'am, is his suggestion right?
Yeah. Well, see, basically, when are you able to do the malware injection? When you are able to access, actually. Like, for example, we talk about that hypervisor attack. So, if suppose, I'll just give an example. Okay, this has made me realize one very good example. For example, one rogue user is there who has realized that a bank is having a VM in particular host. Okay, so that rogue user creates its own virtual machine there. Okay, and is able to do a side channel attack, or you can say co-residency attack. So that is where he can deploy malicious software. So one has to gain access somehow. Okay, that's the first thing. So the moment you gain access, then you are able to rogue user gains an access. Okay, how? That's another story. Gains an access, he or she would be able to lead that kind of attack. Malware, deploying a malware program. Okay, it's one of the egregious 11 that we have just seen. So one needs to gain access. Okay,
Okay,
so
thank
that
you, ma'am.
access control becomes very important.
Yeah. Okay. Thank you so much, ma'am, for sparing your valuable time with us. And I would now like to invite Dr. Imran for presenting the vote of thanks.
Thanks, ma'am, for this nice and informative session. Uh, there is less query because your presentation is so much clear that there are very few queries. Each and everything is clear. Even I have listened the complete your session, very informative session. Thank you, ma'am. Thanks a lot. And I also thanks to my organizing team Dr. Ayan Mustafa Khan, Dr. Saima Bey, Dr. Archana Yadav ma'am, and last but not the least, Dr. Piyush Sharan for his untiring effort. He made this event successful. Thank you, ma'am. Thanks a lot.
Thank you, Dr. Imran. Thank you for inviting me for this talk. I hope I have tried to make the topic as much clear as possible. Okay. Thank you,
Yeah,
Dr.
ma'am.
Imran, and thank you, Dr. Piyush. Thank you. Thank you so much.
Okay, ma'am. Thank you so much.
Okay.
I would now request all the participants to fill the feedback form, and hopefully next time we'll come up with some similar events. So I would like to see more participants from your side. Thank you for patient listening and giving us your valuable time.